Hello guys, today we will see the Leetcode problem number 865. That is the smallest subtree with all the deepest nodes. It is a similar problem to the lowest common ancestor, which is also available on the Leetcode only. So if you have the solution for this problem, so both the problems having the same solution and the same approaches. Okay. So let's see what the problem says to us. Given a root of the binary tree, the depth of each node is the shortest distance to the root. Okay. Return the smallest subtree such that it contains all the deepest nodes in the original tree. So we have to return any of the node which contains all the deepest nodes into it. Okay, as their subtree. The node is called deepest if has the largest depth possible among any node in the entire tree. The subtree of the node is a tree consisting of that node plus the set of all descendant nodes of that node. Okay. So let's see what we have to return here in our answer. Okay. It's a very classical problem which also asked in various interviews. So please be attentive. Okay, so this is our example that here we have to return the lowest common ancestor, we can say. So the lowest common ancestor means the ancestor which is having all the leaf nodes, okay, as their childs. Okay, so here the 2 is having all their childs as a lowest common ancestor. So here 2 can be supposed to be a lowest common ancestor. Now let's take this second example. Okay, second example, we have nothing here given here. Okay, so let's see if there is no if there is this is not present there. Okay, just this these are not present there, this is also not present there, and yes, only 2 is present there. Okay, sorry, one second. Okay, so here okay, so here 6, 2, 0 and 8 and 1, 5 and 3, these only nodes are present. Okay, this 2, forget about these 2 nodes. Now this 6, 2, 0 and 8 are the lowest nodes, that are the leaf nodes which are present. Okay, so it's their level is the lowest. Okay, their level is the lowest, or we can say them as a deepest nodes. Okay, so now we have to find out the node which is which containing their this all the deepest nodes into it. Okay, below it, the node which contain all these deepest nodes below it, okay, as their child nodes. Okay, so this 3 is having 5, 6, 2, 1, 0 and 8 both as their child nodes. Okay, this 3 contains all the nodes at their child node because it is a root. Okay, now after that 5 contains 6 and 2 as their child nodes. Okay, so here the 5 and 2, here the 5 and 2, okay, 5 and 2 contains 6 and 2 as their child nodes, and the 1 containing 0 and 8 as their child node. Okay, now but we want to know the node which contains this 6 which contains this 6, 2, 0 and 8 as their all should be contained in their child nodes. So the lowest common ancestor for this all the nodes will be the 3. Okay, now if we take the another example, if we take, let's say, the another example, okay, we will modify this example only. Okay, so this 0 contains, sorry, this 4 containing their child as a 3 and 5. Okay, okay, now this 7, okay, now let's say, okay, yes, oh, let's see this example. In this example, we have 5 and 3 as the deepest nodes in this tree. Okay, now 5 and 3, so we have to know the node which containing 5 and 3, which containing the 5 and 3 as their child nodes, but that particular node should be the lowest node. Okay, so the 4 now will be the lowest common ancestor for 3 and 5. Okay, both. Now let's see another example. Okay, 7 containing the childs as, okay, 4 and 6. Okay, now 7 is also containing 2 childs. Okay, okay, then now we have to figure out that which lowest common ancestor for this 4, 6, 3 and 5, because this is 4, 6, 3 and 5 having the deepest node. Okay, these are the deepest nodes. Okay, so this deepest nodes we have to figure out what will be the lowest common ancestor for them. So the 4 and 6, the 7 node containing the 4 and 6 but not the 3 and 5. Okay, so that's why we will go upper side and check for the 2. Now 2 is containing 4, 6, 3 and 5 both, so that's why 2 will be the our answer as the lowest common ancestor. Okay, so let's see the solution. Okay, let's see our solution now. So get the depth tree node at a tree root. Okay, so subtree with all deepest, or we can say as a lowest common ancestor code as, okay, now it containing the root, okay, which is given to us. Now we are applying the recursion into the subtree with all deepest function only. So if the root equal to null, so we can return as a null. Okay, in the right depth, what we have to find, that we have to find their depth. Okay, int left depth, we have to find the get left depth of the left root. Okay, root ka left means if we have 3 into it and 4 and 6. Okay, so when we are at the 3, so we have to find out the 4. Okay, depth of the 4 and depth of the 6 means how that if there are further childs of the 4 which is like 5 or 3. Okay, 5 and 3, and 6 doesn't have any of the childs. Okay, so its okay, so its depth will be written as a 1 and this returning 2. Okay, this will return only 1, so its depth will be the depth, both the depth are not same. Okay, so here the right depth is not equal to the left depth. Okay, so now we have to know that if any of the the right child and the left child having the same number of depth. Okay, means same depth of same depth. Just like if we see here, if the right child and the left child, if the right child containing the same depth, means what the depth indicates, the lowest the depth of the lowest nodes. Okay, the depth of the leaf nodes, we can say the depth of the leaf nodes. But here the 6 is also containing as a leaf node. So these 5 and 3 are the leaf nodes, so their depth with respect to the 3 is 1 and 2, but the depth with respect to the 3 of the 6 is only 1. So that's why it will return 1 as a depth and it will return 2 as a depth. So 1 is not equal to 2 here. Okay, 1 will be not equal to the 2. So that's why this cannot be the ancestor. Okay, and if okay, now this cannot be the ancestor, lowest common ancestor. So now our recursion will return which node, which child is having the highest depth. Okay, just like it will return 2 into it. Okay, and it will return 1 into it. Okay, if both are same, so we will return the 3 as our answer. Okay, 3 is the answer if both are same. If same, okay, agar same hota, so if they are same, so we will return 3 as an answer, 3 as the lowest common ancestor. But if they both are not same, so in this case we will return, means we will return in a recursive approach which is having the highest depth. Okay, so then we will go to this side. Okay, now we will apply for the 4. We will find out the depth of the lowest node of 4, left node of the 4 and the right node of the 4. Okay, now it will return to us as a 1. It will return to us as a 1 only. So here we get the same depth for left and right. So that's why we will return it as an answer. Okay, in this. Now let's see the code. Okay, so in this lowest common ancestor we have then right depth and left depth. We are calculating the right depth and left depth. So how we will calculate the get depth? Okay, so get depth is returning the +1, means at every node when it reaches to one node, it will +1. Okay, it will return the +1. So we will get the maximum depth of that for their childs. Okay, then after getting the max depth, so yes, after getting the both the right depth and left depth. Okay, so this is the child depth for the childs. Okay, now after getting that both the depths, we will compare them. If they are both are same, so we will return the root as a lowest common ancestor. But if it doesn't applies, so we will see that which one means if they both are not same. So if with either right depth or left depth, the one from both the depths should be the greater. So that's why we will return that root as the answer, which one having the highest depth, means that root node will having that child node is having the highest depth and will contain the answer as a lowest common ancestor. Okay, so now if the right depth is greater, so we will return the subtree with all depths as a root of right node. Okay, and if otherwise else, we will return the left node. Okay, so this is our solution. and it contains the it is the optimized one, and here the constraints are also very much low, so that's why we can able to write this solution of the n square. Their time complexity will be the n square. And if you are having any of the doubts, so let comment below and I will be clearing your doubts. Thank you.